Okay, this video is on applying the perpendicular and angle bisector theorems. So first of all, let's talk about the perpendicular bisector. So let's say I have this triangle, A, B, C. And this is my perpendicular bisector. So that means, first of all, that the line here is perpendicular to the base, and I bisected it, so this segment, if this is D, AD is congruent to DC, so I can mark that. So then, what this is telling me is if I have a perpendicular bisector, I know, because of the term bisector, that these two segments are congruent. But the other thing that is congruent is AB and BC. So for example, if I knew that AB was 11, BC would also be 11. They are the same. So typically what you will see, though, is not necessarily numbers like this. You might see things with variables. So let's look at another triangle here. We'll do ABC again. And this is D, is our perpendicular bisector. So what I might have is something like side AB is 4x, and side BC is 6x minus 10, and then they might say either what is x or what is the length of BC. So let's do this one as what is x? Solve for x. All right, so what I just told you up here is that these two sides, AB and BC, are congruent because I have a perpendicular bisector. So how would I set up this equation? Right, I would have 4x equals 6x minus 10. I'm setting them equal to each other. And then it just becomes a matter of solving the equation. So I'm going to subtract 6x from both sides. That gives me negative 2x equals negative 10. And when I divide, I get x equals 5. And now that I know x, if I was asked, I could find the length of AB or the length of BC, which are both the same. So really, if I found one, I don't need to find the other. So for me personally, if I was doing this and I needed to know the length of BC, I might plug it in here because it's easier. I have 4 times 5, which is 20, instead of doing 6 times 5 minus 10. But as long as I know this, I can find either side and they're both the same. So let's try one more like this. So here's my perpendicular bisector. And this time we're going to say this is 3n minus 1, this is 5n minus 7. And the question will be, what is the length? Oops, I didn't label this. Let's put some sides on it. P, Q, R. So what is the length of QR? So think for a minute, set it up, and try to solve this one. Okay, so if I wanted to solve this one, 3n minus 1 equals n minus 7. They're equal. And then I'm just going to solve this equation. So I'm going to subtract 5n from both sides. That gives me negative 2n minus 1 equals negative 7. Add 1 to both sides, negative 2n equals negative 6. And when I divide both sides by negative 2, I get n is 3, but that's not the question. The question is, what is QR? So QR is 5n minus 7, or 5 times minus 7. So 5 times 3 is 15. 15 minus 8. So QR is 8, which also means that QP is also 8. All right, so that's the perpendicular bisector theorem. So let's look at now if we have an angle bisector. So angle bisector, let's say I've got maybe M, N, and P, and let's see here. Let's call this point R, All right, so NR bisects the angle. That means this angle is congruent to that angle. That's an angle bisector. And it's a special kind of bisector. This, well, right here, point R, if I draw a perpendicular here and here, so NR is my bisector. I drew a perpendicular line segment to NM, so that's MR, and I drew another perpendicular line segment from NP, which is PR. So these two segments here are perpendicular to my original rays of my angle. So now what I can do with that is I know that these two segments here, MR and RP, are congruent. So I could actually mark this is congruent to this. Which means, for example, if I knew that MR was 3, then RP is also 3. So let's say in this case that MR is 7x and RP is 2x plus 25. And I want to know what is RM. What is the length of RM? So take a moment, set it up, pause the video if you need to, set it up. First you would need to solve for x, and then you'll need to go back in and find what RM is. Okay, so now on this one, when I do it, I know that they're equal. So I set 7x equal to 2x plus 25. Then this is just equation solving. So I get 5x equals 25 or x equals 5, but that wasn't my question. My question was, what is RM? Well, RM is 7x. So RM is 7x or 7 times 5, which is 35. So RM is 35, which also means that RP is 35 because they are the same. So let's try one more like this. So let's do another angle. So we've got, all right, so there's my angle bisector. We're going to call this CF is my angle bisector. So I'm going to draw a perpendicular to that ray and a perpendicular to that ray. And we'll call that point B and point D. And again, at this point, I can mark my picture. That is congruent to that. So now, if this is 6x plus 3, and this is 4x plus 9, let's see. How about on this one? What is the length of FB? So take a moment, pause it if you need to. Figure out what the length of FB is. So this one right here. All right, so again, I know that these two are congruent, so I can write my equation setting them equal to each other, and then I can start solving. If I subtract 4x from both sides, I get 2x plus 3 equals 9. Subtract 3 from both sides, 2x equals 6. Divide both sides by 2, I get x equals 3, but that wasn't my question. My question is FB. So FB is 6x plus 3, which is 6 times 3 plus 3. 6 times 3 is 18, plus 3 is 21. And if FB is 21, what is FD? Right, on this one you don't even have to plug back in because I know that they're congruent. So yes, as a check, I could plug back in and make sure my answer works. I could plug 3 back in here. 3 times 4 is 12, plus 9 is 21. But because they're congruent, if I've solved for one, I don't have to solve for the other.